Oh, wow. Thank you. Oh, I appreciate it. Thank you so much. So I'm Patrick Tucker. I'm technology editor for Defense One. It's a national security news site from Atlantic Media. And before that, I was the editor of a magazine called The Futurist for a while, the deputy editor, I should say. I know, that guy will get mad if I say that. I wrote a book called The Naked Future, What Happens in a World That Anticipates Your Every Move, about predictive analytics, and that came out in 2014. And so that helped me develop an appreciation for how big data is going to change user experience for anyone that accesses the digital world, which is everybody, and how it's going to especially change the future. And that led me to Defense One, where I now cover the effects of emerging technology on national security in like a really broad way. That includes like everything from next generation, fifth, sixth generation fighter jets to Russian election interference to quantum, etc. I don't know how well I cover that breadth, but I get to talk to really smart people all the time, and so most of what I do is telling you what the smart people told me. So sorry about that. Also, if you're, just a heads up, this is not like a super technical talk. There'll be a couple of very sort of elementary terms related to artificial intelligence, but I like can't help you with your Markov model. Like that's someone else, or your regression analysis. If you have that information, please share it with us all during the question and answer period. I'm going to give a little talk, then we're going to open it up for questions and answers about my experience covering the development of artificial intelligence in the Defense Department. And I feel really lucky to be here because of the people that I talk to. This seems like one of the, by far most, like just sort of on it, lit, technically aware, and like on the trend groups that I get to talk to. So I hope you all will talk to each other a little bit too. We'll make this like an interactive type discussion about some of these issues, because the information that you have is every bit as important as the information that I have to me, if not infinitely more so, because I already have my information. I know what it's worth, and now you're about to know too. So like, as I said, I've been covering artificial intelligence in a sort of broad way with The Futurist, and writing my book and at the Defense One for several years, and watched its evolution a little bit, and watched the Defense Department enthusiastically pick it up, and here's where they're going to take it in the years ahead. And before we get into that, though, little like sort of humanities question. Let's see if this works. Oop, let's green. It is advance. There we go. Who knows the etymological origins of the word robot? Raise your hand if you know what language robot is based in. Is it, okay, right here, we've got a volunteer. It is Czech! Oh my God! There's always somebody that knows. It is Czech. It is derived from robota, which is service, derived from the Slavic for roba, which is slave, and it's put into modern usage by a playwright named Karl Čapek, Czechoslovakian playwright, and he wrote a play called Rossums Universal Robots. It premiered in 1920, so it's just about 100 years old. And I bring this up when I talk about artificial intelligence because it's keenly important to understand how our discussion of artificial intelligence, where it comes from, and especially where all of our projections from it come from, because they're actually born into the idea of it at its genesis. So Rossums Universal Robota, Rossums Universal Robots, see if this whole narrative strikes you as familiar. Act 1, an inventor. You might typecast him as an Elon Musk type, or a Jeff Bezos type. Silicon Valley megafauna person invents a new mechanical race of people. They're kind of more like the skin jobs in Blade Runner than something that's like super duper mechanical, but they are definitely in artificial intelligence, and they're meant to do the service of humans. Act 1 is he becomes fantastically wealthy. Silicon Valley wins. Everyone is really excited about this future. Curtain. Act 2, the robots take everyone's job, massive unemployment, civil disruption, civil war, bankruptcy. Act 3, guess who's trying to kill everybody? Go ahead and guess. So this is important because our idea that we're going to first make a lot of money and save a lot of labor off of robots, and then they'll take our job and then they'll kill us. That's something that is a projection that is born into this very idea. So we carry it with us in all of our conversations about that. And before we get to how the United States Defense Department wants to use artificial intelligence, I think that's important to understand that our discussion about this on a sort of emotional level in terms of our cultural history is informed by that projection, and you have to recognize it, put it in a box, understand it for what it is before you can have a real discussion about the very real challenges and the very real opportunities that artificial intelligence has in the future, because employed incorrectly or wrongly, designed poorly, it can have very real and very bad consequences, and you do have to deal with those in a way that's separate from our cultural history of the term. So exponential advancement in artificial intelligence is very much just a trend of life right now. This is one of my favorite quotes about the evolution of this technology. George Plimpton, wonderful writer, the editor of the Paris Review for a long time, was watching Deep Blue beat Garry Kasparov in chess in 1997, and it was a hotel in New York. And he walked out of that hotel and he had this observation about what he had just seen. He said, the machine isn't going to walk out of the hotel there and start doing extraordinary things. It can't manage a baseball team, can't tell you what to do with a bad marriage, right? Now that's 1997, so roughly 20 years ago. Now consider how artificial intelligence has advanced since then, just in terms of what's like constantly screaming across the headlines in terms of tech news that we probably all consume. Consider AlphaGo, the neural net from DeepMind that beat the world's, all the world's best Go champions, like every one of them. Consider how much more difficult Go is than chess. This comes from Dennis Hamblis, he's the kind of guy behind DeepMind, one of the core founders. The number of branching moves in chess are about 30 to 40. In Go, it's like 200 to 250, so it is an exponentially more difficult task. What of this list here would you not trust in artificial intelligence or a robot running an artificial intelligent program to do today? Would you, can they walk? We've all seen this thing of Boston Dynamics and their Atlas robot doing bat flips. They lardar the heck out of that room, I'll bet, before they do that, but we see that. It can walk in the wild. Manage a bad marriage? Does it have access to my entire textual history, my entire email history, what I do at the end of the day, my likelihood of going to the gym versus having a drink? Can it manage all of that data? Can it then output a probability for me of making a mistake in my marriage? It's a possibility. That's realistic now if you consider the applications of big data within artificial intelligence, which is not something George Plimpton really had the benefit to consider when he made this pronouncement in 1997. So digital information coupled with big data, that's what's truly transformative about this technology right now, and also scalable compute. That's what changes this 1997 forecast into something where we see exponential advancement. And it's everywhere. Machine learning is actually everywhere. As I think a lot of folks know, as certainly you guys know, but it's helping my phone find the closest cell tower signal, and then it's determining what objects show up in my Facebook feed, and then it's selling all of that to marketers that then make another decision about what ads to show me, et cetera, et cetera. So right now, as we experience machine learning, when it screws up, when somebody applies it in a way that, or designs some machine learning solution to a problem, whether it's ad optimization or something else, and it screws up, it's less than a perfect solution, the outcome is probably a slight annoyance on my end, or like a smidgen of lost revenue on the end of the advertiser or whoever is using it. And that's going to change as machine learning, low-level machine learning, moves into more and more aspects of life. Who's familiar with this term, narrow AI? It's good, a handful of you. So it's important to sort of break apart the two emerging fields of artificial intelligence. One is far more in the future, it's much bigger. Narrow AI is the AI, the dumb bots that we're dealing with really all the time now and are going to be putting in charge of more and more important functions of life. And there's real risks here in terms of getting these applications wrong, getting the design of these wrong, putting them in charge of the wrong stuff. And that question we need to ask is, did we define this problem correctly, and do we understand the scaling functions? Because when it goes wrong, it doesn't look like an apocalypse. It really looks like this. This is from The Sorcerer's Apprentice, wonderful part of Fantasia, 1950s Disney film. Mickey is a sorcerer, or a programmer, if you will, and he's got a very mundane task. It's very boring, and it's very repetitive, exactly the sort of thing you could apply machine learning to. He has to move a bunch of water from one place to another. He develops a program, which is these brooms that have to pick up the water, and they move it to one place, from one place to another. But he miscalculates both the volume that the water holding container can take and the rate at which they're going to do this, and so he overproduces, and they trample him. And that's an example of narrow AI applied with a poor scaling function, right? Another example is high-frequency trading when you have flash crashes, which are less common now. But this was a big concern, right? Where you have a whole bunch of very simple programs that are trained to dump stock when it reaches a certain level of volatility, or when the price depreciates past a certain point. And then because multiple firms were using them, you had this incident happened where all of them were reacting to what the other high-frequency trading dumping algorithm was doing, and you wind up with billions of dollars of value temporarily lost, and it came back. But this is a real consequential thing. So the question to ask, and this is something that, again, as we approach real applications of artificial intelligence for the military that they're increasingly asking, and they need to ask, and you can help them with, in terms of how you're applying your machine learning solution, in terms of how you're applying your narrow AI, are you understanding the scale correctly? Are you designing or asking the right question? And that's something that commanders in particular are very concerned with when they talk about how AI might help their life. The other brand of artificial intelligence is general AI. This is the one that it's still a little ways off. It's kind of based in neural networking, but really it doesn't exist yet in any form we can point to. And this is the applications of artificial intelligence to a general set of problems. So this is closer to the way a human being thinks, because we are general purpose intelligences. We apply our brain to a set of problems that is general: winning chess, walking out of the hotel room, getting in a cab, fixing a bad marriage. There's a general set of problems. If you have a single artificial intelligence that can handle a wider set of problems than a narrow one, then you have a general artificial intelligence. In many ways, people say that DeepMind might be on the cusp of being accurately described as a type of this, so long as you're giving it rather structured data. If you can gamify your problem set, supposedly DeepMind can handle it really well. But that, again, when we talk about a general set of problems, we're talking about the difference between, versus a narrow set of problems, we're talking about the difference between pretty structured data and largely unstructured data, because that's what we deal with all the time, is unstructured data. That's what we do, is walk around and structure data all day. Like, we evolved our brain over 50 million years to do that. And so there's real questions about how well these systems, particularly neural nets that we're creating, fed with all sorts of open source intelligence information, diagnostic information, whatever you're feeding to it, absent that evolutionary process, there's a big philosophical question about how well they're actually going to do this. And the central questions, particularly for anyone in intelligence in the Defense Department that's looking to harness the next level of artificial intelligence, because they are curious about it, and if it actually stands up, they are anxious to work it into what they do in a way that's safe. But the question is, are we mistaking the judgment of this thing for human judgment? And most importantly, the data that's feeding artificial general intelligence, would we be able to trust it? And again, we're talking about would we. It's all very much in the future. They're interested in this, but general AI doesn't really exist yet, certainly not in a form that's accessible to the Defense Department, but there's signs that it's emerging, and these are the questions that are defining for people that I talk to at the top of intelligence and in the top of the Defense Department. These are the questions that they grapple with in thinking about how to use that or what to do with it. They're reservations, if you will. And It's important because when general artificial intelligence messes up, you have a bad day. As a great example, movie War Games, what happens, you have a general artificial intelligence whose job it is to advise the Defense Department. It's a decision aid, kind of Alexa-like, if you will. It's a decision aid supposed to advise the Defense Department on the likelihood of winning a thermonuclear war, of the proximity of that war. And, well, basically because somebody hooked it up to Matthew Broderick, the data set's all wonky, because Matthew Broderick is the Soviet Union, and he's just playing away in the suburbs, and it goes very bad. So data integrity. We talk a lot about data integrity here. We aren't nearly done discussing figuring out the problem with data integrity. It's hugely important, especially as you get into the question of what you want real artificial intelligence that you can apply to a general set of problems, what you want it to do. It's something that's everyone that I talk to, both in intelligence and defense, is keenly obsessed with. There is no solution for it right now. There's some fun research activity. It's very much an unsolved issue. So the thing is that the military has a mandate for developing artificial intelligence that the rest of the world does not. So we're talking about, when we talk about Uber or a big private company and how they might use autonomous systems in an urban setting, basically replacing their human drivers with self-driving vehicles, et cetera, then we have a conversation about labor and all of these other things. None of these concerns really apply to the military in the same way. The military has to have technological superiority over its adversaries, particularly its peer adversaries. This is core to the new national defense strategy that they pushed out. It's very Cold War-ish sounding. Russia, China play a really key role right up front in terms of what we're developing technology against. We know that there's a lot of research effort there and a lot of funding. So and also the tasks that the Defense Department would put on artificial intelligence are the dumb and dangerous tasks that you don't have to worry about like displacing labor for. Like labor displacement, judgment displacement is a thing, but labor displacement isn't like an issue in the same way. The defense space is going to have a big future on the impact of artificial intelligence because it can bypass labor concerns and other concerns. So it's an exciting time to be talking about this. This is from November of 2014, and this sort of opens the new chapter on the Defense Department's approach to artificial intelligence. The Pentagon announces that they are going to be pursuing a new, what they call an offset strategy, named after the first two offset strategies. This is the third offset strategy, and the origin of that is they're going to offset technological gains that are being made by peer nations by developing new super breakthrough, super relevant technologies for like the year 2030. They're basically going to do kind of like little moonshot stuff, is what the offset strategy was. Big focus of it was artificial intelligence. And later on, me and some other folks figured out that it's not just artificial intelligence, it's this very particular approach to artificial intelligence that's really key for everybody to understand, and that is human-machine teaming. Keeping a human being at the top of the important judgment cycle is core to everything that the Defense Department is trying to do right now with artificial intelligence, as opposed to just remove the human entirely from the important decision cycle. So this comes not from Chuck Hagel, nice guy, absolutely, but then Deputy Defense Secretary Bob Work. Bob Work, who is now at CNAS, was really core to the Defense Department developing its approach to artificial intelligence that they're undertaking today. He read a book by a guy named Tyler Cohen called Average is Over. It's on his shelf. And in that book, Tyler Cohen talks about a guy named Kenneth Regan. Kenneth Regan found a new way to play chess that's better than robotic chess. He found that when you take a human being and you combine them with an exceptional chess-playing robot, then the resulting team beats both the best human chess player and the best artificial intelligence chess player. Bob Work read this, and he said, this is the way to go. This is core to how we're going to approach the development of artificial intelligence. And for the Defense Department, the US Defense Department, it makes a lot of sense. It, number one, keeps like human accountability within the chain of command. They like this. When somebody screws up, they like to be able to say, he's fired, he's court-martialed, he's in trouble, et cetera. Like, it's important to have human accountability, especially for commanders that are, have to integrate international partners in what they're doing, and that's core to this. And also, it makes use of what the Defense Department sees as its most important asset, which is these super trained individuals. The amount of money and time that's poured into training a particular member of military personnel today is enormous. The idea of human-machine teaming to optimize the human decision-making through artificial intelligence that serves in like the support role underneath him, that makes use of both the U.S. need for human accountability, and also the strength, which is U.S. training and U.S. servicemen capable of independent thought. That's something that the Defense Department sees as both a core obligation and a core strength. And so Bob Work developed a strategy for building, developing, and integrating artificial intelligence into military operations that keeps that idea at its core, human-machine teaming. And it's based partially on what he learned about what was then called freestyle chess, but that later became known as centaur chess, where it's human plus a machine. So that's key to everything that they're doing. Beep. So also key to this, Bob Work would go out and he would give talks every so often where he would highlight the particular approach that the Defense Department was taking to artificial intelligence and contrast it with what he saw coming out of particularly China and Russia, and also emphasize that the United States is not alone in attempting to develop, to build, to buy, and to integrate these emerging technologies into everything that they do at a military level. So you can see things kind of moving along here in terms of our headlines. This is the Armata. It's a Russian tank that also has autonomous self-driving capability. And it's a good time to highlight that in terms of how China or Russia employ artificial intelligence in a battlefield setting, we really don't have any clue yet. But we do know that Russian defense contractors like Kalashnikov have advertised autonomous lethal activity or lethal capability as a feature in stuff that they want to sell to the Russian government. And we also know that the Russian government very recently has said, you know what, we can't even define what a lethal autonomous system is. This is a paper that they submitted to the UN. They said, we can't define what a lethal autonomous system is, so we're completely against any attempt to regulate or ban that, right? And China said, well, whatever they said, I don't really know. This is true. We're kind of open to, we're kind of agnostic, but that sounds about right. So that is in contrast to the way the US works. We have a directive, came out in 2012, written by, it was then Undersecretary, I think Deputy Secretary Ash Carter, later became the Defense Secretary, that says that you need to have a human in the loop at all times when you're talking about kinetic activity, when you're talking about actually taking a life. So a human being has to be the one to make the decision to take a life. That's in a doctrine that came out in 2012. It was renewable for a little while. It has since been made permanent, and again, it showcases the core of the way just the Defense Department operates. It keeps human accountability in there, important for chain of command, also important for international partners to have their trust, and it makes use of just the amount of time we spend training individuals to think independently and skill them up to do that. So they like to highlight this contrast. A doctrine is not a law. It is a thing that can change. But at present, this is the Defense Department doctrine, and believe me, I've been waiting to write the headline for a gazillion years. Defense Department now says they're making the killer robots. I've been pushing for it. They're like this. They're keeping this. Mattis in particular likes this. This doctrine, though it is not a law, I don't think it's going anywhere. This remains really core to their approach to this space. So what then have they begun to do with artificial intelligence? In 2015, I wrote this story about special operations forces at the front line and attempts to fuse open source information with a lot of map data, with a lot of other comms, to create a probabilistic scenario for areas that they were going into, very tip of the spear type stuff. And much of the way the rest of the Defense Department is going to approach artificial intelligence is going to be based around that experience to a certain extent. And here's what that is. So the most recent joint strategy operational document It's classified. It's unusual that it is. But after it was classified, the chief of the Air Force, the chief of the Navy, chief of the Army, they all went out and they started giving talks about what they wanted to do for the future, and all the talks made sort of like the same point. We need to connect absolutely everything on the battlefield to absolutely everything else. We need ubiquitous connection across the entire thing. This is the only way we're going to make it past anti-access aerial denial defenses, and that means big radars connected to big missiles and big drones that take off really fast that are going to keep us out of an area. The only way we defeat that is if we connect absolutely everything to everything else, every drone, every sensor on every soldier, every sensor on every car that soldier drives, every satellite, every jet, every ship, every sub, etc., in this huge web that is at once transparent to kind of like every operator at the front line that needs whatever information that can be provided from that web, and certainly transparent from abroad, from combatant commands, from theater commands, from Washington, D.C., from Brussels, from wherever. This ubiquitous connection is core to the way they're moving forward, and most importantly, the way they accept data into a much larger data collection sponge than I think has really ever been achieved by a single institution like on this planet, because it's not just going to be diagnostic data off of one platform. It's really off of all of them, plus signals intelligence potentially, plus commands from human operators or other pieces of intelligence. All of these things that make up this nervous system, it really is that. It's supposed to be a big sensor. It's supposed to suck all of this information that's potentially digitally collectible into a central funnel and then push it out as needed to where it needs to be. And in order to do that task, you need, like in keeping with the vision that they have for it, that's not something that happens without artificial intelligence at an incredibly high scale. So this is a little, can we play the video? This is a little example of what some of that experimentation looks like about a year or two ago. 2015, I think. So then, actual ground infantry comes in behind all that.
We've known for some time, certainly since the OEF era has taken place, that our adversaries are quickly catching up with us.
So they're investing in this areas. We see them moving in areas that we haven't looked at since the Cold War. Everything we talk about, the Marine Corps and a maneuver warfare mindset, is maneuvering faster than the enemy. The operation tempo, moving fast, is what we try to focus on.
It's certainly gotten a lot worse while we were focused on fighting a technological primitive enemy. And what we see now is the anti-access problem has come to the point where we need to start coming up with new ways to do things. And we think technology is part of the solution to that. Going forward, the first one into the room should never be an air breather. It should be a robot with lethal capability. Same thing coming ashore.
Okay, thanks. We can get back to the slide deck now. So yeah, the first one ashore should be a robot with lethal capability. And that doesn't mean outsourcing the kill decision to that robot. They're very clear about maintaining that, but it does mean that the first one on the beach or through that door is a robot with lethal capability. That happened at Red Beach, which in many ways is sort of like the absolute best case scenario for an invasion in the future, because real combat is much more likely to take place in an urban setting that's hard, that's full of complexity. I mean, you want to talk about an unstructured data set. It's an unstructured data set that any human operator is going to have a tremendously difficult time making sense of. So making sense of that is key to this. Taking all of the data that potentially exists, moving it into a place that is understandable to every commander, to every operator in terms of what it is and what they do. There's going to be 44 times as much digital information in the year 2020 as there was in 2009. And this is a quote from IDC that came out a couple of years ago, and it's a good forecast. I think that it might be a little bit of an underestimation. Much of that is streaming data, but it's still data. And that is basically, those are the bricks that the United States Defense Department is looking to use on top of a lot of other things to create next generation artificial intelligence capabilities. There's a couple of projects that you've probably heard about. There's one called Project Maven, a partnership with Google. Google has since said that they want to exit the partnership out of because their employees, many of the developer core has revolted against it, and several have resigned. I can tell you that the Defense Department, everyone that I've talked to has said that that project has been an incredible success. It's basically tagging and identifying objects and images and video footage so that you can cue an analyst to the portion of video footage or that they need to pay attention to. And that is such a success that the Defense Department is actually standing up an entire artificial intelligence institute that's happening later this year. And in terms of, this is they don't talk too much about it publicly, but in terms of the sources that I've talked to about it on background that have been a part of that discussion, what they want to do is replicate Project Maven, which was an Air Force and Special Operations project just across the entire services. Come up with little problems that every service has, perhaps every combatant commander has, and figure out if they can sell them on an AI solution to that problem in order to get buy-in from the services. And then if you have that, then you're actually solving problems in real time as opposed to solving big theoretical things. That's very core to the way what Mattis wants to do. We're seeing that take fruit. There's also a big program that you'll be hearing about later this year if you follow this space at all. It's called Data to Decision. It's an Air Force program as well. It's incredibly ambitious, and that's taking essentially every piece of data that might exist in the air domain or be relevant to the air domain, which is kind of every piece of data. Open source intelligence, social media posts, certainly plane diagnostics, certainly biophysical feedback from pilots, certainly feedback from drones, signals intelligence collection, whatever else, and turn that into something that can serve as a decision aid to a commander. So, and that implies virtually anything that you want to make of it. That implies potentially running counter scenarios to a concept of operations that's currently being employed to see if that, the thinking underlying that concept of operations is still relevant. It's basically everything. It's incredibly ambitious. They're at the very beginning experimental stages of that. They're going to be moving out with more questions about funding that and funding to be awarded as part of that. You also see this huge move to the cloud. And I can tell you that the Defense Department's move to the cloud, both through the enormous JEDI contract and also all the other follow-on cloud contracts that they'll be sending out, are very much related to that nervous system, taking every piece of battlefield data that's relevant, including open source intelligence that is collectible, phone, whatever, and doing something with that that is relevant to every commander, relevant to Washington, relevant to the person on the beach or the person in that urban warfare environment. And Mattis is keen on this too. It has to be relevant to what's called the tactical edge, and that means the guy kicking down the door, walking into all unknown. This cloud has to be relevant to all of them, and it's a huge undertaking. So with that, we got about 17 minutes for questions. I was surprised that I went on so long. I'm sorry. But I would love to hear from you and love to hear your thoughts. So questions about artificial intelligence, the Defense Department, or Defense Department tech in general, or anything. Shoot. That's not me shooting him. It's just...
Thank you for a very interesting presentation. I have a general question. To what role or what extent does Congress have in mandating AI in the Defense Department or even regulating it, just as a broad concept? Thank you.
There might be some aspect of funding the new AI Institute or funding different endeavors that Congress will have some weigh in on. Potentially the House Armed Services Committee and the Senate Armed Services Committee, they are on board with all of this. To the extent that this increases lethality, effectiveness, has the potential to decrease cost. I haven't spoken to a member of Congress that is interested in retarding the Defense Department's emergence into this area. But I can only think of in terms of funding unless they pass some sort of hard law that makes law out of the Defense Department doctrine. That's the only thing that I can think of. No one is talking about doing that, so there's really no meaningful congressional oversight of Defense Department acquisition or development of artificial intelligence that I can think of right now. Other questions? Yes, front row. Oh, wait, we have microphones.
What are the skills that are needed for this? You mentioned people will need to have some sort of skills. And what are the resources that are either available right now or maybe will be available in the future?
That's a very good question, very good question. Well, you're all at an AWS conference, and boy, let me tell you, they really want this cloud thing really bad. And so that's AWS understanding that, and also understanding other cloud environments in a general way will be very important to that. Just in terms of understanding artificial intelligence at its core, statistics. Hugely important. Just learn what a Markov model is and learn who Thomas Bayes was. Like, Thomas Bayes is actually the guy in the background of all of this revolution that we're living through right now. It's a very simple algorithmic approach to probability that can be applied just across all of the other models that really permeate our life right now, with the exception of like a handful. And I would also say open source intelligence verification. Like, there's this whole group of people that exist online now that are actually have become very good within community at understanding the difference between jerry-rigged satellite images and real satellite images, and that's really core to one of the big Defense Department fears, is that they're going to be feeding open source intelligence into some model that's going to be outputting like a prediction about a battlefield outcome, that's going to be outputting some advice, and the adversary is going to be jimmying up all of that open source intel to just be gooey. Very real fear, because that's fake news is a real thing. So that's a core, I think, thing to look into as well. But mostly, yeah, learn database management and fundamentals of cloud compute and statistics. Just general statistics will help you understand artificial intelligence in a way that actually makes it feel relevant to you, and I highly recommend it. Andrew Ning has a course on Coursera that was very helpful on machine learning, and before you take that, retake statistics, is what I would say. Go ahead.
So AI is based a lot on having data available. What sort of posture or investments has the DoD been making in sort of like their partners in trying to get big data on the cloud? Are they going to be mandating that their partners put all their data on the cloud so we can build a AI on that?
That's a very good question. It's probably not going to be. Coming up with a mandate for partners is kind of a quick way to lose a partner. But I do think that they'll definitely be presenting value propositions to international partners, particularly in NATO, in the same way the AI Institute is going to be going to different service components with a value proposition for, hey, give us your data, and that's the main thing that they want. Give us your data, and we're going to output a solution to the problem that you're experiencing. So I do think that you'll see that a lot sooner than you're going to see, hey, you know this exquisite platform that you have, or you know how we're helping you out in this situation? We really need a lot of access to your most closely held information, especially, and we need it digitized and structured in a way that's going to be good for folks in Houston. Can you just do that for us, like real fast? That I see is further off, but instead of a mandate, I think you'll see an outreach for turning data into solution. I'm not sure how great the military as an institution is in that, but there's definitely folks within the military that are very good at that. So hopefully they rise to the top of that effort. Okay, more questions. Here we go, right here in the center. They're looking. I know, no one can figure out which one.
You mentioned adversarial learning being a potential problem for the US community.
Yeah.
Are there any kind of counter-ML efforts to counter what China and Russia are doing with their machine learning?
Well, in many ways, everything that the Defense Department is doing right now in artificial intelligence is based on the at least talking point and the pretense of we have to counter their investment. But in terms of how Russia might deploy an autonomous lethal system to a battlefield in which we might find ourselves, that's a concept of operations concern that I don't think is a concern, but it hasn't been, that I've ever seen, dealt with in a meaningful way yet. It is a concern, and it's also it's something to keep in mind here. One of the things that we're talking about that the Defense Department has not yet solved for, that I think is going to increasingly pressure them in their position and their posture of keeping that human in the loop, is the effect of artificial intelligence on big data on increasing the speed of the observe, orient, decide, and act cycle, the OODA loop. So just basically all operations on the battlefield become faster. As they become faster, they move further away from meaningful human control. And this is something that I talk to people in the Defense Department about at the highest level. They're aware of that they're going to face increasing pressure from pacing and timing to outsource more human decision-making to autonomous entities, to software, to simple machine learning programs, or perhaps something more exotic. And that's in part because they believe that Russia and China is more likely to take that approach because it can accelerate the pace of operations. So that's a real concern. But it's not solved. Yes?
Yeah. Are there any usage of blockchain technology as part of this entire suite of AI developments?
For a little while, the head of DISA, he's now the former head of DISA, but his name is General Lin, was talking about blockchain as one of the potential. DISA is the Defense Information Services Agency. Sorry for the acronyms. I've been in this job too long. I know all that. He was talking about applications of blockchain in secure compute for a little while. I think that you'll see, and then he departed, and it was listed as one potential option among many for just securing communications. I think that you'll see just secure SATCOMs over, using protocols that already exist like MADL and Link 16, et cetera, and also just better and better encryption that's less exotic than you'll see, sooner than you'll see blockchain, just because that's something that the contractors and the comms folks and everybody else is already used to dealing with. So I don't see meaningful movement towards blockchain right now. But it is something that the last guy that was in charge of that agency was willing to talk about a little bit. So if you can provide a solution that's better than those, then I think you've got a case. Okay, yes. Nice suit, by the way.
Thank you very much,
yes.
sir. Appreciate the shout out and appreciate the presentation.
Yes.
Is it fair to say your presentation was focused on kinetic warfare? And one of the challenges, if we're going to have this speeding up of the decision loop, would be around chemical and biological weapons, which I think are back on the table. Many of the moral arguments against them have sort of disappeared in the last numbers of years. So how do you see that sphere playing out?
That's chemical and biological weapons detection is, I think, also an area where you're seeing some research interest, particularly in the placement of ever more exceptional sensors closer to places where those might actually exist, and then making sure that the feedback from those sensors is entering into the larger decision-making cycle. But yeah, there's good money going into and very interesting research coming out of ever better chemical, biological, and also nuclear weapons detection. And much more of that job, importantly, has also been outsourced to special operations forces. And who were adopting and innovating in the AI space before, in a way that other services weren't from a very early stage. So I do think that there's interest in making sure that the sensor at the tip of wherever that might be, especially if it's some potential site of concern, that data is reliable, that it's constant, that it's voluminous, and that it feeds into a decision-making cycle for a commander as quickly as possible. But that's just one of many potential threats. And you're right, I did focus mostly on the robots with guns because we had footage of it. I don't know. I went to a beach and that's what they were using, so yeah. All right, over here.
I'm curious about the use of non-lethal weapons. Is there anything in the DoD policy that might talk about deploying those without a human decision-making process?
Define non-lethal weapon. Are we talking about like information warfare, influence warfare?
No, no. I don't actually work in non-lethal, so I don't know what they are. But as a woman traveling the world, I would say mace and tasers and things that don't automatically result in the death of the person that's on the receiving end.
I know, nice big gray area of the doctrine, isn't that? I can tell you that I have yet to see somebody from the Defense Department or a contractor that was dealing with that, with the Defense Department trot out their mace deploying drone. But there are mace deploying drones, and there are concepts of operation that are being developed for them, and I think it's an area of concern, and I also think it's an area of ethical, that's going to be ethically problematic. And I think that I trust, or believe, or hope, or pray, that really smart and ethically minded commanders, especially those that are most interested in keeping pace with allies that they've roped into different engagement, not roped, that sounds bad, but that have decided to show up with them to a particular engagement. I think that there's going to be real hesitation on their part to deploy some aspect of like a robot with some sort of, I don't know, arresting effect or something like that, some non-lethal force effect against in a situation where they can't control who that adversary is. But it's an area of complexity. There is the Non-Lethal Weapons Directorate. Right now they're mostly focused on jamming trucks that try to charge checkpoints. This is a big area for them. And also direct energy. And direct energy is one of these technologies that you want human control of, and also it's easy to put a human in control of. So that's like lasers, potentially neutral particle beams, and things like that. So that's where I see most of the interest in non-lethal going, is in direct energy and like jamming for vehicle stopping, and less, sticking mace on drones. But you never know, I may be surprised. I don't know. Okay, go ahead.
In pursuit of AI, the more common tech you mentioned before was neural networks. The issue with the neural network is when backward propagation fails, it's catastrophic. You have to reteach the entire neural network, which is really slow. Have you seen any research coming out that will hopefully fix that issue?
Well, in theory, this is why you want an incredibly resilient cloud environment that can only be provided by a massive, commercial entity, because then you can, in theory, you can duplicate what that neural network constructed, and you can bring it back online in case there's a massive failure, in theory. Resiliency is like really core to why the Defense Department wants some enormous cloud thing in the first place. And I think that that is definitely an aspect of just general resiliency, because if you're talking about your neural network going offline, you're talking about all of your comms going. I mean, you're talking about a big potential problem that would affect not just that decision aid, but also potentially a whole bunch of other things, I think.
One more thing, so besides the resilience of the overall network, also the actual neural network itself. So when a neural network mislearns something to reteach something, it breaks neural networking really badly to a point where it takes forever to reteach the entire lessons from father, grandfather, great-grandfather, all the steps.
Yeah.
So is there any research coming out that you've seen that would actually address that issue in the neural networking itself?
Yeah. There would be appetite for it. Like I said, the question of whether or not the output that the neural network is giving you, whether or not it's credible, is of top concern, both for intelligence and DoD, because they have to make decisions about that have higher consequence than folks in the private sector when they make decisions about whether or not to pay attention to an AI-produced output or a neural network-produced output. But in general, I would say that resiliency is like a core concern for them, but it's not something that they've fully solved. Like, you can always get sort of a better resiliency solution. So there would be open to that sort of thing. Anybody else? Okay.
Hi. Good morning.
Hi.
I would like to know if the Defense Department is doing research for medical robots. You might have a soldier who is injured in the battlefield, a U.S. Marine. The medical team cannot get to that soldier. So I think it's very important, that kind of development, or looking into that kind of development. I'm just curious if the Department of Defense is looking into, medical robots.
I think so. You know who's actually pushing ahead on that much harder is NATO. I recently sat down with General Mercier, this French guy. He's like a really optimistic and upbeat French guy. He's like the only one. He's like the emerging technology buyer for NATO. In their next exercise that takes place in November, they're actually going to incorporate what you just described. They want to develop human out-of-the-loop immediate medical emergency distribution. They want to be able to detect from a soldier-borne sensor if somebody's hurt and then dispatch like an autonomous ambulance to go pick them up. So they're actually, NATO is incorporating that into an exercise later in November. And so that's at least one NATO, like US military partner that's experimenting with that, and I think you'll see more. Oh, I think we're done. Wow, look at that. It's like 10 seconds left. Folks, thanks so much. I really appreciate you being here.